problem. So it goes
Mm-hmm.
if A are positive
So this
integers.
is some CMI mock test. Okay.
Yes, the CMI tomato mock test.
Okay.
Yes, A, B, and C are natural numbers, positive integers.
Mm-hmm.
And the GCD of all three of them taken together is 1.
Right.
And it's given that they satisfy the equation A plus B is equal to AB by C.
Okay.
So if this is the case, then we have to prove that A plus B is always a perfect square.
Right.
So, sir, for this, what I actually did was I rewrote the equation as 1 over A plus 1 over B is C.
Right.
I got two solutions.
Sorry, I lost your voice. You got two solutions?
In fact, there are many other solutions for this equation. So how would we do this, sir?
So two solutions means you found like some A, B, and C's which work.
Sir, your voice is breaking actually.
Okay. Is it still breaking? Like,
Yes, I think it's.
yeah, your voice is also breaking.
Oh, no, sir, it's breaking again. 1 second, sir. I'll move closer to the Wi-Fi.
Yeah, just check. Otherwise, maybe if it's my side, then I'll try to change.
Sir, is it better now?
Yeah, your voice is clear. How is my voice? Is it breaking?
Yeah. I can hear you now, sir.
It's not
No,
breaking, right?
it's fine, sir.
Okay, good. All right.
No,
So,
it's not.
okay. So when you say that there are you found solutions, can you give me an example of what solution you found?
So I took C as a constant. So the solutions I got were A comma B is equal to 2C comma 2C and C square plus C comma C plus 1.
Okay. Those some kind of, okay. What was the other one? C square?
Yes. Plus C
Mm-hmm. And
comma C plus 1.
C plus. Okay. I understand. These are going to work, right?
Yeah, but I made a mistake, and of course there are many other solutions. So I don't know what approach to take, sir, because finding the general equation for this Diophantine general solution, I think it's a bit tough.
Let's see. Yeah. So your
Yes.
idea is to kind of find the solution in terms of C, right? So
Yes, sir.
let
Take
me
C as
also,
a constant and proceed.
yeah, let's also try that. So this is equal to 0. Can we
0.
somehow, yeah, so can we somehow factorize this left hand side? We cannot, means by adding something.
Maybe plus 1. Plus 1. Sometimes plus 1 helps a lot.
Yeah, but plus 1 in this case, yeah.
So
Can you think of something?
So alternatively, if we take the GCD 2 at a time, suppose GCD A comma B is equal to D, can we do something with that? Then we will write A is equal to DA naught, maybe.
Yes. So that that also, let's try that. No, but yeah. So let's see. A is equal to d A naught
Yes.
and B equal to d B naught.
dB naught.
Yeah. So if you put that in the equation, then we get A naught plus B naught.
Yes. Yes.
So C is co-prime to D.
Yeah. C is co-prime to D. So because of the ABC is 1.
Yes, yes.
So C should divide A naught or B naught or A naught B naught.
Yeah, I mean C doesn't have to divide A naught. C can share some factors with A naught and could share
Yeah.
some
Yeah.
factors.
Yeah. That's it has
Yeah.
to divide either A naught, B naught, or both, or their combination, or so like that.
Yeah, it doesn't have to. Yeah, it doesn't have to divide either one of them, right? Right?
Yeah.
Yeah.
Correct. Correct. Like for example, if we have C is equal to suppose 3 and B naught is equal to
Three lane is if you
15
take three, then it will divide.
and
No, no, don't take three.
correct. Correct. So but I get it, sir.
Yeah,
I
you
get it.
understand. Yeah, something will work.
Yeah. Yeah. So
But no, but the point is that I mean, if you only do like that, then uh, will it work? Okay, so then it will be like what I'm saying is that let's look at the prime factorization. So this factorization here, I think it will work if you can think of
yes.
something to add here so that on both sides so that it becomes factorizable. If you can think of something, but here what I'm thinking is
Okay.
let's write the prime factorization of A naught. Let us just assume.
Okay. Yes.
And for B naught also, um, let us take Q.
And they'll be disjoint.
They will be disjoint, exactly. Yeah, because coprime.
Yeah.
And
So maybe
yeah, and by the way, yeah, this K I'm taking to be the same. Don't mind it. It need not be the same, I understand.
uh-huh. Yeah,
But
yeah.
just for,
It'll be MN something.
yeah.
Yes.
Then no, then in fact, let's take it to be MNs. Since you are okay with
Yes.
that, then let's take it. Now, how will the prime factorization of C look like?
Uh let's see, sir. So C cannot divide D. So it has to divide A naught, B naught. So it'll be somewhat some primes from P, some primes from B naught. Something like that, maybe.
Yes, yes, right. Some subset of this and some subset of that. Yeah. So it
Some subset, yes. Some subset.
yes. So maybe let's say alpha 1 prime. Yeah. So maybe I will write all of
Yeah.
them and some alpha primes can be 0
Yes, sir.
times. Okay, but so far we are only writing things.
Correct. Sir, so maybe could we consider GCD, BC or something like that?
GCD of GCD
B
DC.
comma C. B comma C.
B comma C, right? Yeah, but that doesn't seem to move in the right direction, right? And I don't know. That seems to just branch
Yeah.
out into more and more.
Yeah. Correct. Correct, sir. I don't think
Yeah.
we're making
So
progress. So.
yeah, here what I'm thinking is that we will need the solutions a bit. Like, okay,
Okay.
what if okay, maybe since I know this trick, I think if you
Yes.
what if you do this?
Correct. So then we take what is that? C common, is it?
Yes, yes.
Yeah, C common.
Now it seems to make
So yeah, it's like we probably can do something. Then we put the minus inside, distribute it inside. Oh no,
uh,
never mind, never mind. Huh.
you see now we have
Okay.
factorized it. Now one observation which is just as a tangent remark is that
Yes.
uh, here we had this thing and it was not factorizable. But whenever it's equations, remember you can always add something. You have the
Correct, correct,
freedom to add, subtract to make it factorizable, which is a little different in
correct,
flavor than usual factorization. Yeah.
correct. Yes, sir. Sometimes I think in Olympiad practice, sometimes you get AB plus A plus B.
Yes,
I
and
think if
this
you
is
add
like
one,
that.
yeah,
That is one, and
yeah,
this is
this
like a
is
C version of, yeah, it's like a no
C.
homogenized of something like that, right? Okay, so now what
Yes,
can
sir.
we say?
So A minus C into B minus C is equal to a perfect square.
Huh.
We've gotten that,
Yes, yes.
and that's equal to C squared. Okay. Um, I was we could split into cases of odd and even, but I don't think that'll help here.
Odd and even, as in?
As in, suppose without loss of generality, oh sorry, not without loss of generality. Case one A is even. What will B and C be? Something like that. I thought of
uh,
doing,
okay.
but again, it seems like it's just branching out, not doing much.
Hmm. Here is one thing that I noticed. So this equation, like this is certainly a solution, right? So this
Yes.
gives me 4c, but so this is a plus b is 4c, but why should this be a perfect square?
Oh, sir, but then if you take 2C, C, the GCD won't be 1 unless C is 1.
Oh, right, absolutely. Yeah, that's correct. Yeah, so
Yes.
it does work.
Yeah. So it seemed like that was a solution. Like I was sitting and thinking about it in the bus. I came up with the solution. I was so confident that I was right, but then my friend gave me like counter examples. So,
Ah, right. Okay.
so sir, any ideas like what can be done further from here?
Yes, yes. So what I what can I say? Yeah. So a minus c times b minus c is a perfect square.
Correct. Yes.
Mm, yeah, it should not be difficult from here, right? After this factorization, should
Yes,
not
sir.
be difficult. Um,
I mean, at least we've gotten a perfect square somehow.
hmm Right. Now, hmm,
Somewhere we'll have to use that condition, sir. The
yes,
ABC.
yes, yes, that's right. Okay, so we can say that a minus c, b minus c, and c. This GCD is also one,
Yes, sir. Correct.
right? Yeah.
Yes, sir. Yeah. Correct. Correct. Yes, sir.
So GCD is one. So
So what if what about the GCD of A minus C, B minus C, and C squared?
that's also
Like,
one, right? That should also be one, right?
so then yes, sir. So then we are getting I don't. Yes, sir. So this leads me to another question, sir.
Hmm.
At what point in solving a question do we abandon a certain method? Like,
Ah,
sometimes I get fixated on one particular method only, and
yes,
if
I
it
was.
doesn't work,
Yes,
if it
that's my
doesn't work, I
problem
try to
also.
modify that thing.
Yes, yes,
Yes,
that is
sir.
also my problem. Yes, I don't know, but I think this from here, I think it should work
Yeah, this seems like it's
the
going to
correct
work,
way.
sir.
Yeah. So, but yeah, let's think about this.
So what if we combine the this method and the prime factorization
Yes, yes,
method?
that's what
What
we
if
have to do.
yeah.
That's right. One second.
So sir, actually my friend who gave me the counter example, he came up with a solution. I'm not sure how much it's right, but Somehow he got that. What he did was he put a into m into l into n, like some set of primes. He prime factorized it. He put b is equal to something else like that. He did, and then some something he did, and he showed that it'll be equal to mln squared or something like that. He did. So I don't have his
Yeah.
exact solution.
Yes, yes. So, so it will be something like that. Just second. So
Yes.
yeah, just a minute. I think so. We are able to say that A minus C and B minus C are also coprime,
Uh, yes, sir.
right?
Yeah. Yes.
Mhm. So this means that A minus C is a perfect square and B
Correct.
minus C is a perfect square.
Yeah. Otherwise, they won't multiply to give a perfect square.
Mhm.
Uh. So then, of course, if we add those, it doesn't help much.
No, but Mn is equal to C. Okay,
Okay.
right?
Oh, so correct, correct. Yes, sir.
Then
So
we are
one
done.
second, sir. So you okay? Oh, this is very simple.
Yes, that's what I mean. I know that if we put all these things in this, it will eventually work out. But the whole point is to find an elegant way,
Okay.
right?
Elegant. Oh,
Matlab
okay.
कि-
Yeah.
matlab a little without being a little lazy. Let's say.
Yes.
So,
Oh,
right,
I should
this
have seen this.
yeah.
Okay. Yeah. This is.
Like I didn't
Yeah. Yes,
use
sir.
yeah. It's like everything got used, but somehow in subtle ways, not the whole prime factorization business and so on, right?
Correct. Yes, sir. Yeah. This is way more elegant than what he did, but I think his answer is also correct.
Yes, it
And
will be.
usually in yes, sir. Usually in CMI mock tests and all, they're very tough questions, but one change of perspective and their answer can be in like 3 or 4 lines, like this one.
Yes, yes, yes. Yeah. I think that's one of the things that just to like or sit back and just try to find some elegant way to make things fit than going for the calculations. Maybe that can
Correct,
be,
sir.
yeah. And maybe like when we go for the
So,
calculations, then we are not able to change our approach also. Then we get very much. Anyways, yes. Oh, you were saying something?
yes, sir. So I was just saying how do you develop that skill? Sometimes I get elegant answers. Sometimes I get 2 line answers, 3 line answers to 10 markers, 14 markers. But sometimes, like I said, I get fixated on one method and it takes me takes me miles away from the question, but still I get stuck to that method. So
Yes, that I don't. I also have that problem. I think that fixation may have to do with, I don't know, maybe we just biased, right? I don't
maybe,
know.
sir.
Yeah, some psychological thing. Yeah. Maybe we are too biased, or
Also one
maybe we really maybe deep down we really don't want to solve the problem, but just want to somehow pass that, somehow, that pressure time. We just want to somehow spend the time doing something rather
yeah,
than thinking about this pressures, like, oh, I'm in such pressure. Um, I don't know. Yeah, it's a very strange. It happens
yes,
to
sir.
me all
Oh,
the time.
and
Yes.
one small correction, sir. I think it'll be m square plus n square plus 2c. It doesn't change much, but
Yeah,
plus 2c.
that's right.
Yes.
Yeah, again, this minus 2c probably I wrote because I you know, was biased towards some, I had something in mind, I just wrote that. These things,
Yeah, it
so
happens.
just happens.
Happens.
One has to have the neutrality, which I don't know how to develop.
It's tough, sir. Like I know that I have to open my mind and But it's tough. It's
It's
tougher
tough.
than
You have to
it's
keep
easier
doing it.
said than
Yeah,
done.
you have to just keep putting yourself in that situation. Okay, I think. Yeah.
Correct.
Okay, so this was a good
But this
question.
was very elegant, sir. I mean,
Yeah, and the question is very
good
good
question, yes,
actually.
sir. Good answer as well.
Yeah. Okay. All right.
So this was asked for 10 marks in the mock test
Hmm.
out of total 100.
Yeah, and don't worry. Like sometimes the CMI mock tests may be harder than the actual CMI paper,
Oh,
but
sir, some are very hard, sir.
yes, some of them are very very. So because this is unofficial, right? This is unofficial paper.
Yeah, it's by I have the book as well, written by I forget his name, so but he's the professor that maintains the site, and it's an excellent resource, especially
Who
for
is he?
CMI ISM.
Who is he?
Uh, I forget the name, sir, but it's something B Rajagopalan or something like that. So I'm not sure.
Oh, okay, okay. I
Perhaps if you can look it up, it's on the site. So there's a book by him, CMI Tomato as well.
okay, okay. Let me check. Yeah, it will be good. I
Yes,
can share it with other people also.
yeah, it's
So
an excellent
B
resource, sir.
Raja Gopalan, or
No,
should
sir,
I? What should I Google?
CMI Tomato, sir. CMI
CM.
Tomato.
So this is CMI tomato. That's interesting. So there was an ISI tomato that we all have. This is
Yes, sir.
CMI
Yeah,
tomato. Oh, I did not know about this book. Wow. Who is the
it's an
writer?
excellent book, sir.
I am very much out of touch. Like I leave these things to the students usually to get the
Uh,
problems going. Um, oh,
and
that's
brilliant students, sir. I've seen the answers on the mock test by some of the
mm,
students. Again, very elegant solutions,
yes,
very
yes.
nice questions, all of that.
These people are. Who is the writer? Where do I find the writer's name?
So if you go to the website and scroll down, I think he's given his number as well.
Bala Sundar M. Okay.
Yes, Bala Sundaram.
I have
Yes, sir.
not heard his name. He's affiliated to, is he a professor? Maths. Oh, okay. So his website will be named what? Balasundar, or what is the name of it?
No, sir. The website is CMI Tomato. Book is also CMI Tomato,
Okay, okay.
and he maintains the website. He conducts mock tests as well, so all that.
Notion Press is the
uh,
name. Okay, so he's a math teacher. Right, right.
yes,
Ah, okay, okay. Right.
I think especially for CMI students, the book CMI Tomato extremely helpful. Like completely
Hmm.
all 20 years solved papers, and it's
Hmm.
divided into subjects, not years. So I think easier to navigate as well.
Nice, nice. Good, good. I see.
Yes.
Yeah, this is a good one. Oh, I did not know about this book. I knew there was a ISI tomato book, but yeah.
The
But
ISI Tomato, even I
yeah, that's a
I've solved
classical.
a few questions.
Okay.
Yeah, classic.
Yeah. Okay. So let's move on to next question.
Yes,
Or like see, so like 30 minutes are remaining. So what happens is the meeting
correct.
ends after 40
Correct.
minutes. So I'll relaunch the meeting once again. Okay, so that it will be uninterrupted.
Same.
Yes, yes.
Okay, sir.
Yeah. Because otherwise it will end in 10 minutes. So then
Okay, sir. Okay, sir.